Homework 6, problem 6, for a point charge Q embedded in a dielectric sphere with susceptibility epsilon, find the applied electric field from the point charge, find the polarization, so the polarization field, capital P, in the sphere, and then find the surface charge, both the bound surface charge and the bound volume charge in the sphere as well. And so for part A, this is pretty easy. The applied electric field, right, is going to be the electric field of the point charge. So this is just Q over 4 pi epsilon naught times 1 over r squared r hat. And so this is the electric field for a point charge. We can just write it down. The polarization, right? The polarization is going to be epsilon naught times this chi e times the electric field, where chi is the electric susceptibility. And so the polarization is going to be two parts here. The polarization is going to be Q times chi e, Q divided by chi e, have to pull that up over to the other side, over 4 pi r squared r hat, and this is for r less than capital R, and it's just 0 for r greater than capital R, because outside of that the electric susceptibility is 0. Okay? So here's the applied electric field, and there's the polarization. The bound surface charge, of course, is n hat dot polarization. And so n hat is going to be, n hat is of course in the r hat direction. N hat is in the r hat direction. And so it's just going to be the polarization evaluated at capital R. And so it says sigma b is going to be Q divided by chi e over 4 pi capital R squared. So that's sigma b. And rho b is minus the divergence of the polarization. And if I want to evaluate the divergence of the polarization in radial coordinates, right, this is going to be 1 over r squared minus 1 over r squared partial with respect to r squared times this. So this will be Q over chi e over 4 pi r squared. Well, the r squareds cancel, and this is going to give 0. And so I'm going to find, for the most part, right, that rho b is equal to 0. Now there is a little bit of a swindle I've done here that I'm sure some of you caught, but hopefully not everyone caught, because that's the answer to part C. And so we'll have to put a question mark by that for a moment. So now we're going to look at the part B. What is the total bound surface charge? Okay, this is actually really easy. It's just the integral b to x of this sigma b. This is constant over the surface, and so this is just the area of the surface, 4 pi r squared times Q over chi e over 4 pi r squared, which of course cancels. And so from this we're going to get that the bound surface charge is Q divided by chi e. Now part C says, but wait a minute, this is not 0. This evaluated to 0 if we did it slightly incorrectly, so where is the compensating charge for the surface charge? Because we know that the total bound charge in a system is always 0 when I have a neutral dielectric. And so where's the compensating surface charge in this case? And so, or the compensating charge to this non-zero surface charge? Well, to do that we have to go back up here and look at what we have. I'm going to rewrite rho b is equal to minus del dot p, and I'm going to pull some stuff out. I'm going to pull out what this polarization is here in the center. This is q over chi e over 4 pi, and then I'm going to get minus a del dot 1 over r squared r hat. Now before, I just blindly applied the divergence operator onto this expression, but I've seen this before. This is the divergence of a point charge, and the divergence of a point charge is not 0, right? It's 4 pi times a delta function. So this is minus q over chi e 4 pi, and then I have 4 pi times a delta function, r, three-dimensional delta function at r. 4 pi's cancel, and this says that my bound charge is not quite 0, right? So this is wrong. My bound charge density is minus q divided by chi e times a three-dimensional delta function at the origin. And so that also answers for that question of where is the compensating charge. The compensating charge is at the origin, because whenever you do an integral, right, so, so rho b is of course minus q over chi e, the three-dimensional delta function. When you do an integral d3x of rho b, this is going to give us 4 pi integral r squared, sorry, this is going to give us minus q over chi e, the integral d3x of delta 3 at the origin, but this is, of course, since my integral will contain the origin, this is just going to give 1, because that's how we define the delta function. The volume integral of a three-dimensional delta function is 1 if that volume contains the point. And so this will be the compensating charge, so QB compensating. And so it's at the origin. At the origin. Okay, so this was just kind of a problem to make you think about the fact that volume divergences can lead to point charges whenever you have a 1 over r squared type function. That's good. Thank you.